This is factoring lesson 3. We're factoring trinomials of the type ax squared plus bx plus c. This is where a is not equal to 1, so we can have another number here other than 1. Previous lesson, these were just 1. If they weren't 1, it was easily factored out. This one, they won't be. So let's see how we can approach these. So there are several methods here. I'm going to show you 2 or 3 of them, and then I'll just let you pick whatever method you find easiest. So the trial and error method. 6x squared plus 17x plus 5. This is, as I recall, this is actually the way that I learned how to do it. This is kind of the way I do it now, but many students don't like this method because it's not as algorithmic as the other ones. It's not as procedural. You have to kind of think a little bit on these. So we'll just go through it, and you can, again, you don't have to use this method, but I want to show it to you nonetheless. So trial and error method is we simply try out a few of them and see which ones work. So 6x squared. Really, there are a couple ways to factor 6x squared. It could be 6x and x, or 3x and 2x. So let's just try 3x and 2x. Now 5 can be factored only one way, 5 and 1. So either it's going to be 5 and 1 or 1 and 5. So let's try the 5 here and the 1 here. And again, the way I do these is I know that I'm going to get this part right. 3x times 2x is 6x squared, and the 5 times the 1 is 5. I'm not worried about that. What I'm worried about is the outer and the inner term. So my outer and inner term, so the outer 3 times 3x times 1 is 3x, 5 times 2x is 10x. What I'm looking at are these two guys right here. Can I combine 10x and 3x to get a 17x? No. That's a 13x. These are all pluses, so I know the whole thing's going to be plus. So let's try the other way. So 3x plus 1 and 2x plus 5. Again, just look at the outer and the inner. So 3 times 5 is 15x. And you can leave the x off if you want to. I know it's going to be an x. 1 times 2 is 2. Can I combine 15 and 2 to get the middle term? Sure. 15 plus 2 is 17. So that is my factoring. If you're showing your work on these, you would rewrite it. You wouldn't want to leave all that there. You would say 3x plus 1 times 2x plus 5. Now, if that one didn't work, I would move to 6x and x. So I have basically 4 choices. And again, the same thing. I have 5 and 1, and then 1 and 5. So that's the trial and error approach. Now, you actually get better at doing the trial and error approach the more you do it. You begin to kind of see where things are how things are gonna occur, and how the math's gonna add up to give you that middle term, and so you can zero in on the 1 or 2 factors that you have. So again, there's the answer: 3x plus 1, 2x plus 5, or 2x plus 5 times 3x plus 1. Let's look at factoring by grouping. So factoring by grouping, what we do is we take this 6 times 5, the a times the c, and we say, okay, I need to find factors of 30 that sum to that middle term. So factors of 30, let's see, 10 and 3, that's not going to work. 5 and 6 is not going to work. Ooh, 15 and 2. So 15 and 2, we're going to sum the middle term. Now, again, it's not as easy. It's not going to be x minus 15, x minus 2, because of this middle term. This term here, a, is not 1. So what we do is we split up this 17x into 15x plus 2x. What? I know. But hang with me here. So 16x squared plus, we're going to rewrite this as 15x plus 2x plus 5. Or you could have said 2x plus 15x. They should both give you the same thing in this case. It doesn't always work out that way. Sometimes the grouping is specific. You have to put these in the right group. So recall when we did factoring by grouping in an earlier lesson. Now we're going to group these up. And now what can I pull out of this first term here? This first group. I can pull out a 3x. What do I have left? 2x plus 5 plus, and I can't pull out anything out of that. In fact, it is 2x plus 5. which is what it needed to be, right? Okay, so what do I have now? I can pull out my common factor of 2x plus 5. I got 2x plus 5, 2x plus 5. Let's pull it out. And I have 2x plus 5. And then what am I left with? 3x plus, when I pull a 2x plus 5 out of the 2x plus 5, I'm left with just a 1. So we get 2x plus 5, 3x plus 1, the same thing I got doing trial by error. This is a little more procedural though, right? It gives us sort of a method, particularly when these numbers get really big. I'll be honest, trial and error is no fun. If I've got 24x squared and a 12, there are just too many choices. When you can have 30 different trials, it gets tricky. Now again, you get better at doing trial and error the more you do it. And the bottom-up method. This is sort of a trick, which I'm not crazy about, but some students really like it, so I don't want to hide it from you. I want to let you know it's there. The problem is that, I'll be honest, I have to look up how to do this method every time I teach it, because I kind of forget it, because it is kind of a trick. It's hard to see why it works. So let's look at this one. 6x squared, again, we're doing the same problem 3 different ways. So it's very similar in how we start the grouping method. We do 6 times 5, 30. So factors of 30 that sum to 17, the middle term. We already know that's going to be 15 and 2. And then what I do is I write x plus 15 and x plus 2. But I'm not done yet. This would not give it to me, right? Because I've got that 6. So what I do, and this is a little wizardy, so I don't really like it that much, but I didn't want to hide it from you. We divide both of these constant terms we have here by the a. We have to reduce. If you don't reduce, you're going to miss it. So now you reduce those fractions. So what, 3 goes into the 15 and 6, so we get 5 halves. And then x plus 1/3. Now what do? I do the bottom up part. So now the bottom here comes up. This 3 comes up. What? I know. So we get 2x plus 5 and 3x plus 1. Same thing we got before. Some students really gravitate toward this method. I'll be honest, I have to look this method up every single time I teach it. Unless I teach this class, a couple times in a row, I'll remember it. It's not bad. It works out, but it's a little tricky, a little gimmicky. So I usually eschew those, but I didn't want to hide it from you. When you're factoring, I'm not going to care how you factor. So I've shown you 3 ways, or probably a couple more. Let's see what we got here. So use any method to factor 2x squared plus 7x plus 6. You may want to try using all 3 on the first couple of these just to see which one you gravitate toward. Okay, so it's hard for me to teach trial and error, so I'm going to do the grouping method and see how we go. So we have 2 times 6 is 12. So factors of 12 that sum to 7. Let's see, 2 and 6. No, ooh, 4 and 3. So 4 times 3. So I'm going to write this as 2x squared plus 4x plus 3x plus 6. Now notice 4x plus 3x is 7x. So, but we don't want to do that because we did this in order so we could group these. So then I group them and then factor out. So we're going to pull out a 2x here, and I'll be left with x plus 2 plus, I can pull out a 3, and I'll get x plus 2. I have a common factor of x plus 2. I can pull it out. And then I'm left with a 2x plus 3. Okay. I'll do bottom up here just so you can see it. First step is exactly the same. except I would, rather than rewriting it this way, I go ahead and write x plus 4 and x plus 3, and then I divide both of these by the a term, reduce, so x plus 4 over 2 is 2, and then that is reduced, so what can I do there? I can bring that 2 up, and 2x plus 3. Again, same thing. We can do trial and error too. Kind of hard to teach that. I mean, I would just basically go through how I trial and error this. I would start with 2x squared can only be factored in 2x and x. 6 has got a couple different ways. I can factor it 6 and 1 or 3 and 2. If I try 3 and 2 first, I know 2 is not going to be in this first group. Why? Because there's not a common factor of 2. If I put a 2 in this one, there's a common factor of 2. So that's one way you can kind of get around not having to try all these. 3 and 2. And then again, I try out the outer and the inner. 4 and the inner is 3, which gives me the 7. So again, that's what I would get. 3 different ways. I'm not going to work in 3 different ways every single time. I'll probably show you the factoring by grouping. Okay, try this one out. Pause the video. On every one of these, I'm going to quit saying pause the video. You know you're supposed to pause it. Pause it. See if you get what I get. You'll get a lot more out of this. You know this by now. If you'll actually try to be working these ahead of me. All right. So factor by grouping. 6 times 5 is 30. And ooh, I solved this one real quick. 5 and 6. So 5 times 6 is 30. 5 plus 6 is 11. 6x squared plus 6x plus 5x plus 5. Now let's group it up. And I can pull out a 6x from this first group. I'm left with x plus 1. And I can pull a 5 from this group, and I'm left with an x plus 1. Again, if this came out to be like x plus 2, it wouldn't work. So if it did this, check to make sure you didn't do something wrong. But if you didn't do anything wrong, then you can't factor it this way. So here we go. We have x plus 1s. I can pull out my x plus 1. And what am I left with? 6x plus 5. And we could have switched these around. We could have put 5x and 6x. You get the same thing on this one. There will be a sum, right? I've seen it before where it mattered how you grouped them up. So let's keep moving on. Use any method to factor. Again, I'm going to do the grouping. It's really hard for me to teach trial and error, even though that's the way I do it. So 10. What do we got here? 7 and 3. I saw that one pretty quickly. And then the 7 has to be the negative one, right? What am I talking about? Not 7 and 3. 5 and 2. And the 5 has to be the negative one. 2 is the positive. So 2x squared minus 5x plus 2x minus 5. And let's group it up. So I can pull out an x from this first one, and I'm going to be left with 2x minus 5 plus, I already have a 2x minus 5 there, nothing to factor out. So pull out your common factor of 2x minus 5, and then you're left with an x plus 1. Again, you should always multiply these back out when you have time on a test to make sure you get your original expression. Okay, 6x squared plus 23x plus 21. Any method to factor. Even if my math lab says use a particular method, it's not going to know what method you used. Use whatever method works for you. So 6 times 21. So 6 times 20 is 120. 6 times 1, 6, 126. So we have 126. So factors of 126 to give you 23. Okay, let me bring the calculator up here. When the numbers get large like this, it's hard to sometimes see what that's going to be. So I'll just kind of start. Okay, 126. Certainly that's divisible by 2, but that's going to be too far apart, right? If I divide that by 2 and 63, I can't get to 23 by that. I'm adding. So 126. So then I'll maybe look at 63. Maybe 126 divided by 6. 6 and 21. Nope. Getting closer though. How about 126 divided by 9? 9, 4. Ooh, there we go. 9 and 14 is 23. So I found it. So it does take a little bit of work on these. There's probably a little program you could download on that if you wanted to. Okay, so now let's continue. So 6x squared plus 9x plus 14x plus 21. Group it up. So pull out 3x, left with 2x plus 3. And pull out a 7. Whoop, I did not mean to have that. So plus 7. And I'll have 2x plus 3. There we go. So I can pull out my common factor of 2x plus 3. And what will I have left? 3x plus 7. This is one I would definitely check out if I were you. 6x squared plus 14x plus 9x. There we go, plus 21. Okay, use any method to factor. 4x squared plus 40x plus 25. It looks like there might be a common factor here, but 4 does not go in 25, so I've just got to proceed. 4 times 25 is 100. So factors of 100, that will lead me to a 40 when I add them up. Let's see, 50 and 2, that's not going to do it. 25 and 4, that won't do it. Again, we've kind of gone through, 10 times 10, 20 times 5, 25 times 4, 2 times 50, that's not going to do it. I've gone through all the ones I could, and I went through a couple more, not going to happen. So this one is prime. Now make sure before you say prime that you really know it's prime. You've checked all the different factors of this. Now example 9. Use any method to factor. 12b squared minus 15b plus 3. So 12 times 3 is 36. So factors of 36. It'll give me the negative 15. Looks like 18 and 3 would do it, right? If that 3 is negative. No? Of course not. That's not going to work, is it? 18 and 3 do not multiply to give me 36. And plus, I need to have, both of my numbers have to be the same sign. That's a plus. That's a minus. So how does 36 factor? How about 12 and 3? So 12 and 3, if both of these guys are negative, I'm in business. So we have 12b squared minus 12b minus 3b plus 3. Now let's go ahead and group it. So put the parentheses. Now when I put parentheses around here, that's going to change that to a minus, right? Because I just put a parentheses there. So I need to make sure that's a plus, so negative, positive. So pull out your 12b. I'm left with b squared minus 1. And then pull out a 3. And you're left with left with b minus 1. Oop, little error here. B squared minus 1. I pulled out a b, so that squared shouldn't be there. You guys were probably yelling at the screen. So poof, it's gone. And now I get my common factor of b minus 1, b minus 1. Let's pull it out. And I'm left with, what, 12b minus 3. Ooh, I see something I should have done. I violated my own rule, didn't I? What could I have done here in the beginning? Pulled out my common factor. That would have made this problem a little bit easier. I can do it here. I can pull out a common factor of 3. And I'm going to get 3, b minus 1, and 4b minus 1. Would have made it a little bit easier on me if I had pulled out a 3 from the beginning. We won't finish it the whole way, but I could have pulled out a 3, and I'm left with 4b squared minus 5b plus 1. And I do the same thing I did before, but now we're just trying to find factors of 4 that sum to 5. That's pretty easy to do, right? 4 and 1, if they're both negative, you get exactly the same thing. Using the method to factor, negative 5m squared plus 40m minus 60. Okay, so here's one I can definitely see to pull out a common factor. It's fresher on my mind now. So pull out a negative 5. You're left with m squared minus 8m plus 12. Alright, my signs are going to change. If I'll pull out a negative, and if I redistribute that through, I'll get my signs back and my numbers back. So this is actually, not a bad problem here. So negative 5. This is back from an earlier lesson. M. So now we don't have a number there, just factors of 12 that are going to sum to 8. Let's see, 2 and 6 if both of these guys are negative. So minus 2, minus 6. Example 11. So now we're just tagging on the same thing we did in the earlier lesson where we were solving these equations. So look back at your example 1, and we're just going to factor this and use what we learned in the earlier lesson on how to solve these quadratic equations. So if you recall, this factored into 3x plus 1 and 2x plus 5. Now what do? Set each factor to 0 and then solve. So the process is exactly the same as we did earlier. We just have to, the factoring part is a little more challenging, and even solving the equation can be a little more challenging. So minus 1, 3x is a negative 1, then divide by 3. So we get x equals a negative 1/3. Subtract 5, 2x is negative 5, divided by 2, x is a negative 5 halves. You can plug both of these in, make sure they work. Example 12. Again, same thing as example 4. So we got 2x plus 3, x plus 2 equals 0. Set each factor equal to 0. And solve for x. 2x is negative 3. X is a negative 3 halves. And this one is going to be x equals negative 2. Subtract 2 from both sides.